Okay, so yesterday we were doing some sequences stuff. Today we're gonna move away from sequences. We're gonna do a series. Now, the first thing is, what is a series? What's the difference between a series and a sequence? It's actually pretty straightforward. A sequence is something like this. A series, instead of having a comma between the digits, you have either a plus, well, if this is for an arithmetic sequence, either you have a plus or you have a minus. So this right here would be an example of a series. It's basically the sum difference, if it's an arithmetic series, or the product quotient of a sequence. It depends on whether it's an arithmetic or geometric. But either you add, subtract, you multiply, divide, and the combination of that sequence is called a series. So let's look at an example. So remember, if it's asking you for the total, the sum, it's probably a series. It's not a sequence. So in a theater, seats are arranged in 50 rows. So you have something like this. There's 50 of them. The first row has 23 seats, and each row contains 4 more seats than the previous row. So how many seats are going to be on the second row?
There's going to be 27.
Yeah, 27, and then 31, 35. There you go. That's our sequence. We have 23, 27, 31, 35, yada, yada. But this question is not asking us for the 50th term. Is it asking us how many seats are there on the 50th row?
No.
No, it's not, right? It's asking us how many seats are there in total throughout all the rows. So this question is not asking you for T50. Keep that in mind. That's not what the question's asking you. What it's asking you is S50, or the S stands for the sum. So we need to find the sum of the first 50 rows. So how do we do this? So there's 2 formulas that you can use. Let me pull them up. So these are the formulas for series of an arithmetic sequence or an arithmetic series. Let's start by using the top formula. Sometimes the top is better, sometimes the bottom is better. If everything is given, then I think the top one is better. So let's see how to use that. So I'm using the top one. So Sn, n here is 50, there's 50 rows. So S50 is going to be equals to everything divided by 2. The n value is 50 times 2 times the first number in the sequence. What's our first number? What's our A value?
23.
So it's going to be 23 plus n is how many rows there are. So in this case, it's again 50. So 50 minus 1. And what's our common difference, D?
4.
4. So we multiply that by 4, close bracket, divide that by 2. And from here, you just plug that in. So 50 times 2 times 23 plus 49 times 4 divided by 2. So that gives me 60/50 as the final answer, okay? So in total, in this theater, there are 6,050 seats. So that's if you use the first formula. Sometimes you won't have the common difference value D. They might not give you this. What they might give you is that in the 50th row, there are a certain number of seats. Instead of giving you the D value, they will give you Tn, or in this case, they'll give you T50. So how do you use the bottom formula? To use the bottom formula, either Tn has to be given, or you need to find Tn by using the sequence formulas that we used yesterday. Here, Tn represents how many seats are there in the 50th row. So since we don't have this, we need this to find our S50. We need to find T50 first. The formula for Tn is A plus n minus 1d. So for T50, it'll be 23 plus 49 times our d value, which is 4. This is, again, the number of seats in the last row, in the 50th row. 49 times 4, so that's 219. Now that we have our T50, we can use the bottom formula. S50 is equals to n, which is again 50, times 23 is our T1. Our Tn, in this case T50, is 219. And we divide this by 2. So let me plug that in. 50 times 23 plus 219 divided by 2. That also gives me 6050. And there we go. That's the answer to this question. So both of them would work. The top one is usually easier because you just plug everything in. You don't have to find Tn. But if the D isn't given, if the final term of the sequence is given, then you want to use the bottom one. Does this make sense?
Mhm.
It's just simple formulas. Two of them depends on what you're given. And everything is like this. Let's try doing some of these. I'm going to keep these on the side. So for this question 6, it says, determine the sum of the first 20 terms. So we're trying to find S20, right? Not T20, we're trying to find S20, sum. We're going to use the top formula. N is 20. A is given here. The first term is 8. N minus 1 would become 19. Common difference is 5. And then you divide this by 2. You plug that in a calculator, you're done. Easy as that. Straight up plug and chug. What about for part B? Which formula would we use? The top one or the bottom one?
The bottom one.
Yeah, we're trying to find S20. So this becomes N, which is 20, times T1, which is 31, plus Tn. Now Tn is the 20th term. So that's going to be 109 divided by 2. So in this case, it's easier to use the bottom one because we're given the nth term. And that gives us 1400, and that's the answer to part B. What about this one?
Can you use the second one?
No, you don't, because for the second one, you would need T20. Here we only have T2. So you can't use the second one. So for part C, you need to find the D value and use the first one. What's our common difference here? Remember how to find D? D is going to be T2 minus T1. For geometric, it's T2 over T1. So here it's going to be 53 minus 37. That's going to be 13 plus 3, negative 16 as your D value. And using this, you have to use the top one, okay? The bottom one here doesn't work because you don't have T20. I guess now that you have your D, you have your T1, you could find Tn first and then plug it into the second one, but just plugging this as is into the first one would be easier. So here S20 would be 20 times 2 times 53 plus 19 times negative 16 all over 2. You want to use the top one. And D is again T2 minus T1. What about this one? Part D, do we use the top one or the bottom one? Or do we need to do something else? So this one's tricky because for both of them, you need your A value or you need your T1. Here we don't have our T1. What do we have? Do we have our D value?
Mm-hmm.
Yeah, we do. D is 17. So the next term increases by 17 units. So if your T4 is 18, what's your T3?
11.
1, right? Minus 17, not minus 7. It's going to be 1. T2 would be 1 minus 17. It would be negative 16. And T1, or your A value, they mean the same thing, would be negative 16 minus 17. That'll be negative 33. So you need to work backwards first to find your A value. And from here, you're just going to use the first one. It's a plug and chug, right? You have your A, you have your D, you plug and chug into the first formula there. What about this one? What do we know?
D is 3.
Yeah, we're given D. D is minus 3. But here, going 15 times backwards might be a little bit annoying. And sometimes they might even say the 150th term is this. So here we're missing the A value. Last time it was pretty simple because we were given T4. Here we're given T15. Remember the formula for Tn. Tn is A plus n minus 1 times D. So T15 is 107. Tn gets replaced by 107. A we don't know, but we know n minus 1 when n is 15 is 14, and we know our D value is negative 3. So we end up getting this equation here, which will help us find our A value because A is going to be 107 plus 14 times 3, right? Like that.
Mm-hmm.
107 plus 14 times 3. So that gives us our A value of 149. We have our A, we have our D. We're going to use the first formula there. It's just a plug and chug there, and you are done. So if the A value is missing, you're given Tn, you're given D. First find your A by using the sequence formula. Tn is A plus n minus 1D, and then you can plug it in there. What about for part F? What are we given? Do we have our D or A? So here we don't have A nor D. So if you don't have both of them, it's probably a system of linear equations question. So here T13 is 109. Remember the formula for Tn? It's A plus n minus 1. So if n is 13, it'll be 12 times D. So that's our first equation. What's our second equation? What goes on the right-hand side of this equation?
A plus 60.
A plus 60. So this becomes a system. Then you subtract. A will be gone. 60 is 6, 4. So D is 46 divided by 6, which is not a nice number. That is 23 over 3. You can plug this in any one of them. I'm going to plug it in here to find my A value. So 43 is A plus 6 times 23 over 3. So 43 minus 6 times 23 times 3. A value is -3. So there we go. We found our A, we found our D by using the system of linear equations. And use the top formula and you're done. So usually it becomes a combination of the sequence and the series formulas when you're dealing with series, because not every time they'll give you the A and the D value to begin with. Let's look at this question with this blurry picture. So someone's jumping out of a plane. In the first second, so this is the plane. Someone's jumping out. During the first second, they've jumped 4.9 meters. For each second afterwards, she continues to fall 9.8 meters more than the previous second. So when t is 2, how far has she fallen? It would be 9.8 meters more than previous, right? So it'll be 4.9 plus 9.8. So that will be 14.7. Yeah?
Mhm.
T3 would be 14.7 plus 9.8. So in other words, what we're given here is that the A value, T1, is 4.9 meters, and your common difference D is 9.8 meters. And where does this 9.8 come from? You'll do this in physics. This is called the acceleration due to gravity, G value. On Earth, it's 9.8 meters per second squared. This is a measure of acceleration, which is change in speed over change in time. And on this planet, it changes slightly, but 9.8 is good enough. It's like usually like 9.79 to 9.81-ish. It's dependent on the height of the surface that you're going towards. So if you're going towards a mountain, you'll be pulled less. If you're going towards the surface of the ocean, you'll be pulled more. but on average, it's 9.8 meters per second squared. That's where the 9.8 comes from. What's the question asking us? How far did she fall after 15 seconds? All right, so is this asking us for T15 or is it asking us for S15? What do you think?
S15.
Yeah, it's asking us for S15. T15 would be the difference in the height between when T is 14 and when T is 15. This would be T15. Whereas S15 would be the sum from the very beginning. And that's what this question is asking us, the total distance from the beginning. Do we use the top formula or the bottom formula? You have your A and D, you're going to use the top one. Okay?
Mhm.
And that's it. You just plug it in. It's very simple. 15 times 2 times 4.9 plus 14 times 9.8 all over 2. So 2 times 4.9 plus 14 times 9.8 times 15 divided by 2. The answer is that she's fallen 1102.5 meters in 15 seconds. So a little over a kilometer. And that's it for this question. It's not too bad if you're able to recognize what it's asking you. If you're able to recognize it's asking you for S15. Let's look at this one. We're working at an assembly line, Jamal is, on the 20th day. So T20, on the 20th day, he assembled 137 toys. He noticed that since he started, every day he assembled 3 more toys than the day before. What letter is used to denote this 3?
D.
So we know our D. Question is, how many toys did he assemble all together during the first 20 days? So what is this question asking us? S50 or T50? Sorry, S20 or T20?
S20.
So if you look at the formulas, both the top one and the bottom one, they both use the A value or the first term. We don't have the first term, so we have to find it. Remember, so if this is missing, you need to use the sequence formulas. Tn is A plus n minus 1d. We know T20, that is 137. A is missing, and minus 1 becomes 19, and D is 3. So this way we can find 137 minus 57. That's going to be your A value. That's 80. So if you have your A value and you have your Tn, you probably want to use the bottom one. That's less computations. So you'd use the bottom one. So here S20 would be n times your A value, 80, plus Tn value, 137, divided by 2. And let's plug that in, and that'll give us the total number of toys assembled. So that's 2170. And that's the answer to this question. Cool?
Mhm.
This is not too bad, right? You just use the sequence formula sometimes if the A is missing or the D is missing, and you're going to use one of the two series formulas to find the sum. Now let's look at this one. So in a game called Geometric Constructors, a number of shapes have to be arranged in a predefined form. So here in level 1, you're given 3 minutes and 20 seconds. What's 3 minutes and 20 seconds in terms of seconds?
It's 320 seconds.
No, it's not. Try again. How many seconds are there in 3 minutes and 20 seconds?
200.
200. So, and then at T20, we're given 145, so that's 105, right?
Mhm.
So the question is asking us, what would be the total amount of time to complete the first 20 levels? So you're looking at S20. Do we use the top one or do we use the bottom one?
Bottom one.
Yeah, you'd use the bottom one. It's very simple. It's going to be 200 plus 105 over 2 because we're given Tn. So 20 times 200 plus 105 divided by 2, it's going to be 3050. And that's the end of the question. Easy peasy. 2 steps. Yeah, this one is going to be a little bit trickier. What we're given here is the 10th term of a series. So we're given T10, it's 34. What else are we given?
S20.
So in this question, neither A nor D is given. All right, cool. So let's start. So if nothing's given, it's probably going to be a system of equations question. So for this one, I'm going to rewrite this as A plus 9D. Can I do that? Yes, you can, because this is a formula for T10. So that's our first equation. I'm just gonna write it in this form in case we need to do substitution. Let's look at S20. To find S20, let's use the top formula here, this one. We don't know A, we don't know D, but that's fine. We know what our N is. N is 20. So it's gonna be 20 times 2A. We don't know what that is, but that's fine. 2A plus N minus 1. So it'll be 19. Yeah.
Mm-hmm.
19D divided by 2 is equals to 710, like that. What I'm going to do is I'm going to clean this up a little bit. So I'm going to multiply both sides by 2 and divide by 20. 710 times 2 divided by 20. That gives us 71. Like this. Now I'm going to do a substitution. I'm going to replace this A with this term. So it'll be 2 times 34 minus 9d plus 19d equals 71. And we're doing this because we don't have a nor d. If both of them are missing, it's probably going to be a substitution elimination question. Here, we could have also used elimination using this and this. You just multiply equation 1 by 2, but I think substitution is easier here. So I replace the a in this second equation using what a is from the first equation. So then this becomes 68 minus 18d plus 19d is 71. D is 3. If D is 3, we can plug it right back in here to find our a value. It'll be 34 minus 9 times 3. It's going to be 7. So a is 7. Okay?
Mm-hmm.
From here, it's easy. It says find 25th term. T25 is a plus 24d. A is 7. D is 3. So it becomes 79. And you are done with this question. So this one was slightly tricky because we had to use, we had to turn this into a system of linear equations using the S formula. We haven't done this thus far. We used 2 T formulas, but here we had to use 1 T and 1 S, which made things a little bit trickier. And that's why you should do, if A and D are both missing, it's always going to be a system question. But again, there's only 3 formulas. These 2 and the third one is the one for Tn. So how hard could it possibly be? Let's look at this question, 16. Tell me what we're given here and what the question's asking us. What's our A?
1,
What's our D?
3,
Do we know our N value? No, we don't. That's the missing component. It's asking us for how many terms there are, so N is missing. But we do know something. How would you denote 1001?
S,
So that's going to be Sn is 1001, okay?
mm-hmm.
Because we're given A and D, I'm going to use the top formula. So Sn, we're going to replace Sn with 1001. That is equals to N. We don't know what N is. Times 2 times A, so 2 times 1 is a 2, plus N, again, we don't know what that is, so we can't open that bracket. It'll be N minus 1 times D. We do know what D is. D is a 3 divided by 2. There we go. This becomes a, probably is going to become a quadratic. I'm going to multiply both sides by a 2. Let's kill the fraction. We have N, we have 2 plus 3N minus 3. I open this bracket up top just to compile the like terms. Next, we're gonna do 2 minus 3. So you get N times negative 1 plus 3N is equals to 2002. If we open this bracket, what do we get? There's a square bracket here. If we open it, if we FOIL it, what do we get?
Negative n plus 3n squared.
Yes. So 3n squared minus n, right? And remember, for a quadratic, for any polynomial means when the power is 2 or above, to solve that polynomial, you need to bring everything to the same side. So I'm going to move the 2002 onto this side as well. So we get a 0 here, and then you have to subtract 2002 to take it onto the other side. So you get minus 2002. How do you solve a quadratic equation? You use man, or you're going to use the quadratic formula. In this question, I would not use man because the numbers that it multiplies to is negative 6,006, and it adds up to -1. What are the numbers? Who knows? There's many combinations here to check. So the man approach is not that efficient. What I'm going to use here is the quadratic formula, which says your missing variable. In this case, it's n or x, whatever. Here it's n. It is negative b plus minus b squared minus 4ac over 2a. This is the quadratic formula where a is 3. A is the number attached to the squared term, so 3. B is the coefficient of the power 1 term, so b here will be -1. What's our c value? C is the intercept, or the constant. Negative 2002. We're going to plug all 3 of those variables into the quadratic equation. So negative b becomes -1, becomes a +1, plus minus. B squared becomes a 1, -1 squared is a 1, minus 4 times 3 times negative 2002, all over 2 times 3, like that. So this becomes 1 minus 4 times 3 times negative 2002. The square root of this guy is 155. So 155 over 6. So what this means is that you have 2 different answers. Remember, quadratic, you can have two x-intercepts. One of them will be the plus, so you do 1 plus 155 divided by 6. The other one will be the minus, so it'll be 1 minus 155 divided by 6. So 156 divided by 6 is 26. 1 minus 155 divided by 6 is negative 25.67. Can your term number be negative? Can term numbers be negative?
No.
No, it cannot be. So this answer is moot. So therefore, your final answer is 26. There are 26 terms in this series, okay? So that one was a difficult question because the n was missing. And that's going to be the case if for a series, if the n is missing, then it's no longer going to be a linear. Let's move on from these guys. As you can imagine, the next topic is going to be geometric series. And again, the goal is to find the sum, okay? To find the sum. Just like before, there's 2 formulas for this one. One of them is better than the other, depending on what's given. So let's pull up this fish picture. And I'm also gonna pull up the formulas. All right. Let's quickly look at the formulas. The top one uses A, R, and N. So if you have the common ratio, the first digit, and the term number, you're going to use the top one. Whereas for the bottom one, you don't use N. There's no N the formula uses, but it uses Tn plus 1. Now this is going to be super confusing to think about. Let me explain to you what Tn plus 1 is. Your series is 1, 2, 4, 8. Let's say there are 4 numbers in your series. 1, 2, 4, 8. A is 1, R is 2. Remember, R is just T2 over T1. The common ratio is what R is. So here R is 2. This is the end of your series. This 8 is your Tn, the last term in your series. Tn plus 1 actually goes one step above your series. It goes beyond the last digit of your series. You need to go one step higher. 16, which is not part of this series, but it would have been the next term. That is Tn plus 1. Okay? You need to go one digit above the end of the series to find Tn plus 1, which is a little bit confusing. So let's read this question. So there's a hatchery. In the hatchery, yada yada, the number of fish hatched on the 4 days. Okay, so here we have N, and then we have Tn. On day 1, we had 2 fish. Fish. Day 2, we had 10. Day 3, we had 50. Day 4, we had 250. And then the question is asking us, what's the question asking us? T10 or S10?
That's 10.
S10. So we need to find the sum of this entire thing. All right, so let's use the top formula. S10 is going to be A. So A is 2, the first digit. What's our R value?
It's 2.
Nope. Try again. R is not 2. R is a common ratio. R is T2 over T1. So what is it?
5.
5. R is 5. If you have A on R, just like we did for arithmetic sequence, if you have A and D, you're going to use the top one. So we're going to use the top one here. So it'll be 2 times R 5 to the power of 10 minus 1 all over 5 minus 1. Just following the formula, tit for tat. So 2 times 5 to the power of 10 minus 1 divided by 4. It's a huge number. It's 4,882,812. Cool?
Mm-hmm.
That's using the top formula. But this is the thing again, right? Yeah, you can, if the pattern continues, you're going to get 4 million fish, but usually you're never going to get this many fish because there is not enough resources in the river, in the lake, in the hatchery to accommodate this many fish, right? So probably like you'll get a few thousand and then you're going to hit your carrying capacity, the K value. So in reality, it won't actually go to this number. If it did, then the people would be rich. Like even if you sold it for like 50 cents each, that's a lot of money. It's kind of hard to fathom how big of a number this is. Like 4 million fish is a huge number. Our minds can't comprehend large scales. So that's if you use the top formula. How would you do this question using the bottom formula? then things become slightly tricky. Here, you don't have to use it, but I'm going to show it to you anyways. Let's say in case you wanted to use the bottom formula to check your answer. Step number 1 is you need to find your T10. In fact, you need to find your T11. Because although the question is asking us for S10, this formula uses one step above. So even though we're looking at the first 10 terms, Tn plus 1 here represents T11. So step 1, you're going to find this. Remember, for a geometric sequence, the formula for Tn is a times r to the power of n minus 1. So here a is 2. To find T11, a is 2. R is 5 to the power of 11 minus 1. And we're finding T11 and not T10 because in a geometric series, it doesn't use Tn like it did for arithmetic. It uses Tn plus 1. So it'll be 2 times 5 to the power of 10, which is going to be another huge number. That's going to be 19,531,250. So that's our T11. Now we can use this formula. So S10 is T11 minus T1 over R minus 1. So here this would be 19,531,250 minus 2 is T1 divided by 5 minus 1, 4. And that gives us the exact same answer as we got before. So if A and R are given, probably the first formula would be easier. But if Tn is given, you know your R, you can easily find your Tn plus 1. In that case, you want to use the second formula. And that's the end of this question, okay?
Mhm.
So again, geometric, just be careful. The bottom formula uses Tn plus 1, one number higher than the n value. So this question is asking us to find the sum of the first 7 terms. So again, we know we're trying to find what S7 is. This is the goal, which means n is 7. Here we're given the first term, so A is going to be 11. What about this number, 704? How would you denote this?
It's just T7.
It's T7, yeah. All right, so now we've hit a bit of a conundrum because we don't know what R is, right?
Mhm.
So as of right now, you can't use the top one or the bottom one. But we should be able to find the R value because we're given T7. The formula for geometric sequence is Tn is a times R to the power of n minus 1. So T7, n would be 6. That's 704. A is given, A is 11. R is missing to the power of 6. 7 minus 1, 6. So this is the equation that you get. How would you find the R value for this? How do you solve for R?
You divide by 11.
And then? If you
You
divide,
do the sixth root of
yeah, you
7.
do the 6th root. You do the 6th root. It's n minus 1, so you do the 6th root. It's going to be 2. So R is 2. Let me show you how to use both of them formulas. If you use the top one, S7 is A, which is given in the question, 11, times R we know now is 2, and is 7 minus 1 divided by R minus 1. So 11 times 2 to the power 7 minus 1 divided by 1, that's 1397. Now let's say you want to use the bottom one. You're feeling brave. Yeah, you could. But we need to find Tn plus 1. What does Tn plus 1 represent here? If you're looking for the first 7 terms, Tn plus 1 represents T8. Okay?
Mhm.
We're given T7. We know what our R value is. What would be T8?
You multiply by 2.
Yeah, it'll be 1408. You just multiply 704 by 2 to get 1408. And this formula here uses T8. That's the gist. That's why we need to do this. To find the sum of the first 7 terms, you need the 8th term itself, T8. That's going to be 1408. Let me plug this in. And as you don't even need to use a calculator here. 2 minus 1 is a 1. You can completely ignore it. And 1408 minus 11 is 1397. So both of these approaches would work, okay?
Mhm.
It really depends on what you're given. Let's do one difficult question and we'll call it a day. So here we're given a geometric series. T1 is 23, cool. T3 is 92. And sum of the series. We don't know how many terms there are, but we do know the sum is this. And the question is, what's n? Right now, we can't use either of the formulas because we don't know the R value. Let's attack this. Tn is A times R to the power of n minus 1. So if T3 is 92, what does this equation become?
23 times R to the power 2.
Yeah. So 23 times 2 is 46 times 4 is 92. So R is going to be 2, okay?
Mm-hmm.
Now we're going to use the top formula because we don't know the n plus 1th term, so the bottom formula is useless. So Sn is 62813 equals A times 2 to the power of n minus 1 all over 2 minus 1, which is a 1. You can ignore this denominator. So let's divide both sides by 23 and add 1. So 2732 is 2 to the power of n. How do we solve this for n? You're
You
going to
do log.
use, yeah, you do logs. So n is going to be log 2732 over log 2. And that gives me n is 11. Cool?
Mm-hmm.
So if the n is missing here in a geometric series, then it becomes an exponential equation where the unknown is in the exponent. Whereas if n is missing for an arithmetic sequence, it becomes a polynomial. Usually a quadratic is what it becomes a quadratic. But here it becomes an exponential equation. That's the difference between them. All right, let's call it there for today.
Thank you.
See ya.